Hey there, and welcome. So today we're going to talk about a little piece of everyday magic, the QR code. You know, how you can scratch it, tear it, or even have a big chunk missing, and somehow it still works. How does it do that?
Yeah, let's just jump right in. You've totally been there, right? You point your phone at some coffee-stained menu or a crumpled-up poster, and that little black and white square still manages to take you to the website. It's like, how is that even possible? Is your phone just, I don't know, guessing? Is it magic? Well, the short answer? Nope, it's not magic at all. The real secret is this incredible combination of math and logic. It's a system so smart, it can literally rebuild itself from the inside out. So yeah, let's break it down.
Okay, so to really get how this works, we first have to appreciate just how tough these little squares are. They're basically, in a way, digitally unbreakable. So a QR code, which stands for quick response, by the way, isn't just some fancy-looking barcode. It's a full-on data storage system that was built for the real world, the messy world. And its biggest superpower? It has this built-in ability to fix itself when it gets damaged. All right, so to see that superpower in action, we've got to perform a little digital dissection. Let's pop the hood and take a look at the anatomy of a QR code. A QR code is actually structured a bit like a living thing, with its own body organs. See those three big squares in the corners? Those are the finder patterns. Think of them as the eyes. They help your phone find the code in the first place. Then you've got the smaller alignment and timing patterns, which are kind of like the skeleton, keeping everything straight even if you're holding your phone at a weird angle. But the real secret, the key to its toughness, lies in those last two parts, the data area, where the actual message is, and the error correction area. That's where the backup plan is hiding.
Right, so this error correction area is the key to everything. Now, it's not just a simple copy of the data. That would be way too inefficient. Instead, it's a set of mathematically generated backup info. A good way to think of it is like a blueprint, one that can be used to rebuild the original message if any part of it gets wiped out. And this brings us right to the core of the QR code's genius, its secret backup plan. This is the reason a little smudge or a tear isn't a complete catastrophe. So let's go back to that big question. How can a camera read a code when part of it is literally missing? Well, the answer isn't in the camera itself. It's all in the software, in the algorithm. And here it is, the hero of our story. It's a super powerful mathematical method called Reed-Solomon error correction. And this isn't some brand new tech either. This is a battle-tested algorithm that's been keeping our data safe for decades. And just look at where else it's used. This stuff is seriously robust. We're talking about the same math that kept your old CDs and DVDs from skipping when they got scratched. It's the same system that protects communications with satellites and deep space probes from, cosmic rays. So yeah, if it's good enough for NASA, it's definitely good enough for your takeout menu. So the easiest way to wrap your head around this is with a simple idea: redundancy. Imagine you wrote down this sentence: study, 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 smart, 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 math, 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 right? If I came along and smudged out a few of those words, you could still figure out the original message pretty easily, couldn't you? Reed-Solomon does something kind of like that, just way, way more sophisticated, using pure math. And what's really cool is that you can actually choose how much backup you want. QR codes have different strength levels. You've got level L, which can recover from about 7% damage, all the way up to level H, which can reconstruct the message even if almost a third of the code is gone. So you're probably wondering, why not just use the strongest level all the time? Well, it's a trade-off. The more backup data you have, the less room there is for the actual information you're trying to store. So someone might choose level L for a really long website link, but they definitely pick level H for a QR code on a public poster that's going to get rained on and scuffed. Okay, so we know how much data can be brought back from the brink, but how does this mathematical rescue mission actually happen? Let's walk through it step by step. Okay, first up, whatever message you're storing, like a website, gets turned into numbers, into binary, to zeros and ones. Step 2, the Reed-Solomon math kicks in and creates all that backup data. Then, step 3, and this is so important, the original data and the backup data are woven together, spread all across the code. This is brilliant because it means one big scratch can't just wipe out all your precious original data. It's going to hit a mix of original and backup info, which makes it much easier to fix. Step 4, well, damage happens, the code gets scuffed. And finally, step 5, you scan it, the app sees the gaps, runs the Reed-Solomon math, and like a detective, it perfectly reconstructs the missing information. And it's really important to remember who's doing all the hard work here. Your phone's camera? It's just the eyes. All it does is take a picture of the code. The scanner app on your phone, that's the brain. It's the software that's doing all the thinking, analyzing the picture, spotting the damage, and running all those clever equations to perform the rescue.
So, as we start to wrap this up, it becomes pretty clear, right? What looks like digital magic is really just a beautiful and incredibly practical use of math. So let's just recap. Why are QR codes so unbelievably reliable? Well, first, the data is stored with backups built right in. Second, they use powerful math to predict and fix errors on the fly. And third, all that information is spread out logically, so one big problem can't take the whole thing down. It's just a masterclass in smart, resilient design. So really, the next time you scan a beat-up, worn-out QR code and it just works, take a second to appreciate the sheer elegance of what's happening. Those aren't just random black and white squares. They're true mathematical masterpieces, quietly and reliably doing their job all around us. And that kind of leaves us with one final thought, doesn't it? Our world is absolutely filled with this kind of hidden genius, from how your phone filters out background noise on a call to how GPS figures out exactly where you are. So my question for you is, what other magic in your daily life do you think is actually just really clever math at work? Think about it. Thanks for joining me.